Welcome to Mathlink, where we connect the dots. I am Mr. C, and in this unit, we're going to talk about ratio and also proportions. So let's get started. Before we do some examples, let's get some definitions. So a ratio is a comparison of two like quantities. The terms of a ratio must be compared in the order in which they are given. Terms must be expressed in the same units. The first term is the numerator of the fraction, and the second term is called the denominator, which is on the bottom. The ratio should be expressed in the lowest fractional terms. So for example, let's look at this ratio are expressed in two different ways. With a colon, 4 to 9, so that's how we read it, 4 to 9, 4 to 9, and with a division sign that separates it. You can say 4 over 9 or 4 divided by 9. All three ways are correct. 4 colon 9, and how you say that's 4 to 9, or 4 over 9, like I said before, which is the bigger number that you see on our screen, and in, which is really division. So ratio are really division problems. So ratio is division problem. And notice it's at its lowest term. You don't want to say 16 over 36, even though they're equal, you want to reduce it to be 4/9, or you want to say 4 to 9. So here's an example. Express 5 to 15 as a ratio in its lowest term. And so how we do this, a couple ways you can do it. You can write it as 5 to 15, excuse me. And then you can reduce that. 5 goes into 5 one time, 5 goes into 15 3. So that's 1 to 3. And so that'll be the answer for this particular one. Now what I want to look at is the comparison of two proportions. So we'll look at the word proportion or ratio numbers, but I'll look at proportion, use that as an example, where we have an unknown for the numerator or for sometimes for the denominator, and the other three numbers are known. So how we can look at this is we say f over 6.3 is equal to 9.8 divided by 21.7. I want to find what is that x value that makes it equal. So I got to find that value. So in this way, we can do something called cross multiplication. I'm going to use a green line to show you this. So I can multiply, removing my denominators up to my numerators. Now, this is one way how you can look at it, but I'm going to clear it. I'm going to show you something here to make a little shortcut that you may appreciate here. So let's clear our marking. And again, with our marking, these are equal. So all I need to do is get rid of the 6.2 to get f by itself. So in this case, what we can do, we can say f is equal to get by itself. We have to move this 6.2 up on the top is 6.2 times 9.8, and all that's divided by 21.7. And that's how I get my f by itself. So once I do the math here, this gives us approximation about like 2.8, I believe, around there. And that'll be our answer. So f has to equal 2.8 for those proportions to equal. Now let's talk about direct proportions. There's two types of proportions we're going to talk about today, direct and indirect. And so if we understand what direct means, it makes the problem a lot easier. And if we understand what indirect means, again, we know how to set it up a little bit differently. But let's talk about direct proportions. Two quantities are directly proportional if a change in one produces a change in the other in the same direction. And the key is same direction. So make sure if you're writing this down, pause the video, write that down. It must be in the same direction. When setting up a direct proportion in fraction form, you said numerator, denominator. I'm going to show you how you can, there's different ways to set it up. But so I'm going to look at an example how we can look at something that's directly proportional and how to set it up. So let's look at this example. It says a machine produces 280 pieces in 3.5 hours. So in 3.5 hours, we produce 280 pieces or whatever. Now, how long does it take to produce 720 pieces? So we want to figure out that time, how many hours? So is this direct or indirect? Well, the answer is it's direct. What I mean by direct is I have a number of pieces within this certain time frame, and as I increase the number of pieces, my hours increase. So that's direct, because as I have more pieces, my hours increase. Is direct. So how does that look? How do we set that up as far as directing? So we analyze an increase in the number of pieces produced requires an increase in time. So that's the same. So that's what we mean by same direction. One increase, the other increase. So how we can set this up, I'm going to go back a little bit, is we can say this. There's a couple ways you can do it. We can say the 3.5 hours, and it doesn't have to be exactly this way, but this is one way to look at it, divided by 280 pieces, okay? So the 3.5 over the 280, those numbers are together because that's what's happening, is equal, directly proportional to, we don't know X, but we know that the pieces is going to be 720. So see how I set it up? Hours is on the top, and on the bottom, we have our pieces, and it's directly proportional. So directly proportional, you set it up similar to this. Now in this case, I'm going to move that 720 up. I'm going to multiply, move that 720 up. And let me just change the color of the blue so we see what we have here. So we have, I'm going to move X over here. So this would be X is equal to 3.5 times 720 divided by 280. Now we got X by itself. And if we do the math correctly, I believe this would be 9, and always write down your units. It'd be what, 9 hours. So then this would be our answer. So 9 hours will produce 720 pieces. So there's an increase of hours there. Now let's talk about inverse proportions. Two quantities are inversely or indirectly proportional if a change in one produces a change in the other in the opposite direction. The key word is opposite direction. This is our key concept. Opposite direction. Two quantities are inversely or inversely proportional if an increase in one product is a decrease in the other, and a decrease in one product is an increase in the other. So they're opposite directions. So this is where we have the inverse proportions. We're setting up inverse proportion. We set up a little bit different. So let me show an example and see how we can set this up. So let's see this example. Let's read it and see how we set it up. So 5 identical machines produce the same parts at the same rate. Okay. The 5 machines complete the required number of parts in 1.8 hours. So 5 machines produce the same amount of parts in 1.8 hours. How many hours does it take for 3 machines to produce the same number of parts? So as we look at that last statement, that question, if we have 3 machines, what will happen? Well, and you got to think, is it directly or indirectly? So with 3 machines, we're actually going to be, in this case, we analyze a decrease in the number of machines from 5 to 3 require an increase in time. So that means it is an inverse proportion because there's an opposite thing that's happening, opposite direction. So think about it, 5 machines, 1.8 hours, but if you have 3 machines, it's going to increase your hours. So since it didn't decrease, it increased, this is an inverse proportion. So let's do this particular problem too and see how we can set it up. Now, I want you to think about how I want to set this up. It's a little different. Again, we can use what we had before. So we have, in this case, let's start with 3. So we have 3 machines. And underneath there, we're not going to put down, because we're using a relationship, we're not going to put down X far as hours. We're actually going to put down the 1.8. Normally, if it was directly, we say 3 over X because we're trying to figure out how many hours. But in this case, we say 3 over 1.8 is equal to, again, machines are on the top, hours on the bottom, 5 machines, and in this case, over X. So it's kind of different because we're doing an inverse proportion. And I did that on purpose. So the tops are the machines, and the bottom, in this case, is our hours. And notice the 3 is not with X. 3 is with 1.8 because it's indirect. It's inverse proportion. Now, in this case, we need to solve for X. And I'm going to show you this particular way. We're going to move X up here and move this 1.8 up. So in this case, we have 3X is equal to 1.8 times 5. Divide both sides by 3. Therefore, X is by itself is equal to 1.8 times 5 divided by 3. And if we do the math for that particular piece, X will equal to, I believe, 3, if my math is correct on this. And I'll just circle that. And then that'll be my answer. It'll be 3 what? 3 hours. Always write those units. So it'll be 3 hours. So let's look at one more problem, see if it's direct or if it's an indirect proportion, at least get the idea, and then how to set it up. So here's our problem. A piece of lumber is 2.8 meters long and it weighs 24.5 kilograms. A piece of 0.8 meter long is cut from that 2.8 meter length. So we're cutting it a little shorter. It says determine the weight of the 0.8 meter piece. So let you think about it. Is it directly proportional or indirectly? So since we have a piece of lumber and we have the weight, we cut a little bit from that piece of lumber. I'm going to have, in that case, we're going to have a lesser weight than a 24. So that's a direct proportion. Smaller length, lesser weight, direct proportion. So how do we set this up? Let's do this. So I could say 2.8, I'm going to use my meters on the top over the weight directly, 24.5 is equal to, let's do our meters again, on the top 0.8 and on the bottom our weight. In this case, we cross multiply, and what we have here is X times 2.8 is equal to 0.8 times 24.5. And that 24.5 looks really bad, but that's what it says. So let me rewrite it again. So x is equal to, if I get x by itself divided by 2.8, it's going to equal to 0.8 times that 24.5 divided by 2.8. Now, once you do the math there, multiply the numerator, then divided by 2.8, we should end up with the number 7, I believe. So that'd be 7, what? 7 kilograms. Is that what we're looking at? Yep, kilograms. And that's our answer for this problem, will be 7 kilograms. Now, I hope this helped. Again, look at the video again and look at some of our supplementary material on our Mathlink website. Again, let Mathlink bring it together.